sampling techniques. So I'm going to go through the main types of sampling methods that you need to know for this course, okay? Now, basically there are two types, non-random and random, okay? So on this page, we have the non-random methods, okay? Now the first one is the simplest one. It's called convenience sampling. And basically, as the name suggests, you pick the people who are most convenient. So you don't really take any effort in trying to find the people. You just basically do it out of convenience. So for example, if I wanted to work out who the students were going to vote for in the student election, one thing I could do is stand outside the front door and just pick the first 20 students that come through the door and ask them, who are you going to vote for in the student presidential elections? So that would be convenience sampling, because I just basically stood there and waited for the students to come and for me to ask them. Or I could go into a random classroom, or just any classroom or classroom I teach, and just pick the first 20 students that I see. Okay, so you don't really put much thought into how you're going to select people. You just do it in the most convenient way possible. Usually the first people you kind of see. So obviously the advantage of this is that it's easy to carry out, okay? But the disadvantage is that it's likely to have some kind of bias, because it could be at the time that I was standing by the front door, there was, let's say, more year ones coming through the door. So the data would be biased towards the opinion of year one. Okay, so it wouldn't be a representative sample of what the school thought or how they would vote in the elections or whatever. Okay, so this is the simplest one, convenience sampling. Now, a little bit better than that is to use what's called quota sampling. Okay, and what this does is, for example, I might pick 5 students from each year group, because I would realize that perhaps the different year groups will vote differently in the elections. So I will pick a quota from each year group, okay, and I will ask, so the first, let's say, 5 year ones I see, I'll ask those, and then the first 5 year twos I see, I'll ask those or whatever. So again, you still use convenience sampling while you're doing it. There's no kind of random sampling where you're picking people at random. You're using convenience sampling, but you are choosing certain quotas. Okay. Now, to do it properly, we would have to work out the number of students in each year group and make sure that our sample is in the same proportion. So, for example, if there was twice as many year 6s as there was year 1s, I need to make sure my sample has twice as many year 6s than year 1s, and everything has to be in the right proportion through the year groups. Okay, and this was how this guy George Gallup conducted his poll. If you remember, we were talking about the 1936 presidential elections. That's how he did it. He worked out how many people were in all of the different socio-economic groups and made sure his sample had the correct proportions, okay? And then he told his people who were collecting the data, right, you need to get 1,000 of these people, 1,000 of these people, and so on. And they just went out and found people to fill those quotas, okay? So again, it's important to remember that this is non-random. Okay, you're still using convenience sampling to collect the data from the people, or choose the people, but you are actually using these kind of quotas so that it should be in proportion. So advantages of this is it can be used where the population is large, and random sampling would be too difficult, because to do random sampling, you basically have to make a list of everybody, which is obviously impractical for the whole country. So it's going to be easy to do, but the disadvantage is you need to know the percentages of the different groups, the different strata in the population. Now, if I was doing it for our school, I would have that information about how many students there were in each year group. So that would be fine. Another disadvantage would be that it can be biased because it uses convenience sampling. Okay. So you're still picking, although you're getting the right quotas in the different groups, you're still just finding them by, for example, just going into a year 1 class and just picking the first 5 people you see or whatever. Okay. Okay, the next thing is the random methods. Okay. Now, the first one is simple random sampling. Now, this is simply where you make a list of everybody in the population and you pick them all completely at random. So everybody has the same chance of being chosen. Now, you might think, well, why can't people just pick somebody at random? I'll pick him, 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 him. Well, it's been found from experience that human beings are pretty bad at making random samples. Just unconsciously, they can bring in some bias in who they choose. So a good way to do it is just make a list of everybody and put the names in a hat or something and pick them out randomly. Mostly it's done by using random numbers, okay, which would make sense. Okay, so yeah, that's simple random sampling. Now, the good thing about that is that it usually produces a representative sample, okay? But we saw when we were doing the Desmos task on the star map that sometimes just by pure chance you accidentally choose too many of one particular group than another. So usually it's okay, but especially if you have a small sample size, it can still have some bias in it. Okay. The disadvantage, of course, is that you need to have a list of everyone in the population. So in our school, that would be fine. I can just get a list of the 370 students and generate the random numbers and just pick them and then just go and find them. Okay, so that's simple random sampling. Another method is systematic sampling. So there's some kind of systematic. And what happens here is you make a list of everybody in the whole school. So you would have your 370 names on a list, just in some kind of order. And then let's say you needed a sample size of I don't know what you would need. Let's say 10. Okay. So if you need a sample size of 10, you're going to have to basically take every 37th person, yeah, to get up to 370, yeah. But you have to make it so that obviously you don't just pick the first person on the list and then count 37 after that and so on. You have to pick the first person at random from the first 37 people. So you'd get a random number from 1 to 37. So let's say 15. Then you'd pick the 15th person. Okay, you pick the 15th person and then you just count 37 after that and get that next person. So you keep adding 37 and taking that person until you get to near the end of the list. So systematic sampling is just taking they're giving an example here, every 5th person or whatever in a list. But you need to start at a random place at the top of the list, not the first person. So that's another way of doing it. It should come out to be random, okay? So it should usually produces a representative sample, but the disadvantage is, again, you need a list of the whole population, and it can be biased if there's some hidden pattern in the list, okay? So yeah, in a list of people from our school, I'm not sure how often that would happen, but it could be that certain surnames, are particularly together, and then you can't have two of those people from those nationalities or something because they're more likely to have those types of letters. That's the only thing I can think of in that case. But it's possible that the way that you list the data it can have some hidden pattern which then produces a bias when you're picking every 10th person or whatever, and then it actually accidentally hits on those people somehow, or misses out people because of the way the list has been arranged. Okay, but usually it should be random, and then it's easy to do as well. Okay, right, the final one, again, these are all random methods on this page, is the one we did in the Desmos task, which is stratified sampling. Okay, and this is generally the best one because we saw from the simple random sampling, sometimes you can, by pure chance, get more from one particular group than another. So it's not quite in proportion anymore. Okay, so for example, if we're doing it in our school and I do a simple random sampling of the year groups, and I know I should have, and I basically, just by pure chance, I have, I don't know, more year fours, a lot more year fours than year threes, just by accident, just by randomness. It obviously would be, there would be some bias there because I've got too many year fours compared to year threes. So with stratified sampling, what we do is we take the important groups where we think it's going to make a difference. So in my case, the year groups. And again, it's the same as quota sampling. You divide them up into the different groups. They're called strata. Okay, so in our case, year groups, year 1, 2, 3, 4, 5, 6. And we make it proportional to the numbers in the population. So if I've got twice as many year 6s, I make sure I have, than year 1s, I make sure I have twice as many 6s than year 1s in my sample. Okay. So the only difference between stratified sampling and quota sampling is that quota sampling, once we worked out the different proportions we needed, we used convenience sampling. Okay, so once I'd worked out my quotas, I just went into the classroom and found the first 5 year 1s. But with this one, once you have the numbers you need from each group, okay, you have to find those people at random. So if I know I need to have 5 year 1s in my sample to keep it all in proportion, I need to pick those 5 year 1s at random. So I'd have to make a list of all the year 1s, and then I don't know, get 5 random numbers and pick those 5 people. Okay, so that's stratified. Okay, and it usually will give you a more representative sample than the simple random sampling, assuming that there is a difference in the groups. If it doesn't matter, if the year 1s are going to vote in exactly the similar way to the year 5s and year 4s, and everyone, there's no difference in the year groups how they vote, then it won't make a difference. But if there is a difference between the different year groups voting who they vote for, then this will make a difference and it will be more representative because you will know you have the right number of each year group in proportion to the actual populations, the actual year groups. Okay, so the advantage is it's going to produce a representative sample, and the disadvantages are the same as before. You need to have a list of everybody in the population. Okay, and you need to have information about how many people there are in each of the different strata. Okay, so just to recap then, we have the non-random methods of convenience sampling, which is just finding the first people you can basically, or in some convenient way without any randomness. The quota sampling, where you divide them into the correct proportions, but then you just use convenience sampling to find those and fill those quotas. Then we have the random methods. You have the simple random sampling, which is just basically making a list of people and getting you random numbers and just getting those people. The systematic sampling, which is basically every 5th person or whatever in the list. And the stratified sampling, which is very similar to the quota sampling with the different, dividing it up into the different groups in proportion. But this time, once we've got the different quotas, the different proportions or numbers from each strata, we use random sampling to find the people.